Hey guys, welcome to the Level 2 NCEA Algebra paper from 2021. Um, Basically how this video works is I go through each question, work out the answers, and let you guys know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, have a go by yourself just to see how far you get with the question, and then unpause the video just to see, compare your answer with my answer. So without further ado, let's get started. All right, guys, so we're going to start off with question 1a here. And I guess we've got simplify each expression, leave it in positive indices. So the first thing you really want to make sure is that you actually put a little 1 where the 3 and the y is. And of course, the reason we do this is so that we can actually remember that it's also going to be 3 to the power of 4 when we expand the brackets. So this becomes 3 to the power of 4 and y to the power of 4. And that whole thing is divided by 3 to the power of, 3 times y to the power of -1. Now, 3 to the power of 4, the way I would do it is because it is got the same base. So I could actually rewrite this as 3 to the power of, I'm going to do 4 minus 1. And then I've got y to the power of 4. Let's just put this in a different color then. Then I've got 4 take away -1 from the denominator. So what we end up with is 3 to the power of 3 and y to the power of 5. Now 3 to the power of 3 is, geez, just having one of those days, isn't it? 27. And then we've got y to the power of 5. So 27y5. Checking the grades, this is actually worth and achieved. And then we're going to look at the second question here. With the second question, what we've got is we've got to get rid of that square root symbol. So we can rewrite this as 8y 27 to the power of 1/3. So, if you remember, when you have square root, it's to the power of half. So in this case, we're going to actually put it as 1/3. And remember that 8 has a power of 1. So we're going to get 8 to the power of 1 times 1/3 and y to the power of 27 times 1/3. Now 8 to the power of 1/3, if you kind of like, oh, I can't remember what it is, just what you could do is just make sure you put it in the calculator. Now here's a little tip for you guys when you do 8 to the power of 1/3. Let me see if this is actually going to work. Yeah, it's not going to work. And the reason it's not going to work is you have not put the bracket around 1/3. And this is one of the common mistakes people do when it comes to using the calculator. So when you go 8 to the power of 1/3, just make sure you put in with the brackets, and what you should get is 2. And then y to the power of 27 times 1/3 is 9. So you're going to get 2y to the power of 9. So this question also is gets with an achieved. Anything else? Sorry, just checking the marking schedule here. No, we are good. We can actually go to the next question. Okay, so the next question, what we have is we've actually got two solutions here for a quadratic equation, and we've been asked to find the original equation. All right, now they're actually telling you guys that you have to give the answer of as ax squared plus bx plus c. But also, I think the key thing is to notice that a, b, c, they're actually whole numbers. All right. So now, and I know that I've kind of talked about this before in my, I think I might have done it in my tutorials in the previous years. Do check it out, guys. There's like tons of tutorials out there, like the old ones that I've done. Still quite relevant. But anyway, let's have a look at this. So what I would do in this case is, it's kind of like going backwards, right? What I mean by that is like if I have x equals to 4, I can rewrite this as x minus 4 because then that's what that factor would be. Now, if you remember a quadratic, so let's say I'm going to do this backwards here. So if I have like x squared plus 3x plus 4, not 4, let's go 2 equals to 0, I'd actually write this as x plus 2, x plus 1 equals to 0. Therefore, x is equal to 2 or x equals to 1. Okay, this is an example right here. So going backwards, I would just rearrange that equation. And so that's what I'm doing here. But however, when I have x equals to minus 2 over 3, The problem is, I mean, you could actually say, well, why can't I just do this? X plus 2/3 equals to 0. Yeah, that's great. There's nothing wrong with it. But the issue is that if you look at the question, A, B, C, they're actually whole numbers. And in this case, you're not going to end up with a nice equation. So what you do instead is, so instead of doing this, what you do instead is cross multiply the 3. So you write this as 3x equals to minus 2. And then bring the minus 2 to the left-hand side, which will make it plus 2. So I've got 3x plus 2 equals to 0. And what we have right now is we've actually got two factors. So our first factor is x minus 4, and our second factor is 3x plus 2. So we need to give the answer in this ax squared plus bx plus c format. So what we have to do is then we actually have to expand the brackets and simplify it. So we're going to get 3x squared plus 2x minus 12x minus 8. And putting it all together, we're going to get 3x squared minus 10x minus 8 is what my equation is. So that's the original equation that we have. But we do need to remember that they're actually asking for like original equation. They're not asking you for just the brackets. Now, because we had two answers, we have to remember that the original equation is actually equal to 0. So what can we do here? Yeah, no, that's pretty much it for this question, guys. And I know that this question has actually come up in level 3 as an achieved as well, especially at calculus. I've seen it with complex numbers, but you'll know a little bit more about that next year. So for question B, if you get the final line, you're going to get a merit. Correct equations, but coefficients not whole numbers or incorrect. La, la, la. Okay, right. So if you end up using this as one of your factors, then your equation is going to look something like this. I should really do this as in blue. So I'll not blue, red. So you could do x minus 4 times x plus 2/3. Let's say you did this. If you did it and you expanded it, what would happen is that you won't get it as whole numbers, but you could still get an achieved for it. Okay, so that's it for this question, guys. We move on to the next one. All right, let's have a look at question C here. All right, so with question C, I mean, I'm looking at the answer schedule and there is a couple of answers. And in fact, the first method that I look at it, I'm going, geez, that's quite easy. But the thing is, like, I mean, you've got to actually start to look at an equation and you kind of go, right, what can I actually do with this equation, right? Like the way I would do this, if I was sitting in the exam with you guys, show that one solution is twice the other solution, I would just put this in a quadratic formula and get my two answers just to see what happens. That's what I would do. All right, so that's what I'm going to do in this case, and then I'll show you guys the other method that the answer schedule talks about as well. So I've got a value of 1, which is, that's what my a value is. Then I've got b value, which equals to minus 3k, and c value equals to 2x squared. So just to reiterate, there's my b value, and then there is my c value. So at the moment, then what I can do is I could actually work out the two solutions by saying, just putting the quadratic formula. So I've got minus b plus or minus square root of b squared minus 4ac over 2a. So now minus b, that's going to be negative 3k plus or minus square root of negative 3k squared minus 4 times 1 times, what do we got, 2k squared, and divided by 2. So I've got 3k, because two negatives make a positive, plus or minus. Now the negative 3k squared will become positive 9k squared, minus, I got 4 times 1 times 2, that's all going to be 8k squared over 2. So I can rewrite this now as 3k plus or minus square root of k squared over 2. Still carrying on, I've got 3k plus or minus k over 2. So this is what my two solutions are. So my first solution is going to be 3k plus k over 2. And my second solution is going to be 3k minus k over 2. And when I do this, I am going to get 4k over 2 and 2k over 2. What have I got here? 4k over 2 is 2k, and 2k over 2 is k. So in here, you can actually see that 1 root 2k is double the other root. So this is one way of doing this question. So obviously I kind of just went, sorry, I should have actually put this, there's my b value and c value. So I should have actually, how do I say it? Like, I mean, this is the way I would have approached this question now, because it's like, I'm trying to find out solutions. The moment I'm looking for solutions, I'm just going to put it straight in the quadratic formula. Now, like I did say at the start of this question that I was going to show you guys what the examiners thought, or like, what sometimes a shortcut is, right? So they actually did this. They recognized this straight away. So here you've got x squared minus 3kx plus 2k squared is equal to 0. Now, what I'm going to show you guys is this, right? Imagine if you had something like this, x squared minus 3x plus 2 equals to 0. We could actually write this as x minus 2 times x minus 1 equals to 0. So based on this theory, when I actually have x squared minus 3xk plus 2k squared equals to 0, I can factorize this to x minus 2k and x minus k. Because if I expand this, I'm actually going to end up with that ugly looking quadratic up at the top. And guess what? When I solve this, x minus 2k is equal to 0, so x is equal to 2k, or x minus k is equal to 0, x is equal to k. And as you guys can see, both answers there, both methods that you choose, you're actually going to end up with the same answers. So achieved for this question, if you factorize the equation, so which is like, let's say you got up to here, you can actually get an achieved. Or if you could get an achieved for getting this k squared value as the discriminant in that quadratic equation. Finally, for the merit, you do need the two solutions, and you also need, I would actually say, just get into the habit of writing the statement as well of what it is that you just, what you're trying to figure out. Cool, so that's it for this question, guys. We move to the next one. All right, guys, so with the next question, what we've got here is there's two curves, and we're trying to find out the coordinates of each intersection point of these two curves. Okay, so what I'm going to do is I'm actually going to put this in the graphics calculator just to kind of get a gauge of where these equations are. So we've got y squared plus, that's a bit annoying to kind of do that. I see. So how would I do this? So for starters, y equals to x minus 1. So I'm going to do that one, all right? So I'm going to put down x minus 1, and then what do we got? X plus 1, x plus 1, minus 2. So that's my first graph there. Oh, I think I made a mistake. Did I? Yes, I did. Got the bracket there. X minus 1, x plus 1, minus 2. Yeah, that looks good. I wonder if I can do type. No, I can't do it here. It's going to be a bit weird, guys, but I'm just going to write this as y squared, so square root of x squared minus 1. So I'm going to do this, square root of x squared minus 1. Now this is going to be one part of it. So let's just draw it and see what happens. And obviously there's going to be a second part of it going down like that as well. So I just need to figure out how do I do that. So I'm going to go, that's the excess part of it. So I'm just going to draw that quickly, which is x squared minus 1. Is that going to work? Ah, yeah, there we go. So yeah, basically what I did there was like, when you do square root graphs, it only does the top half of it. So by putting a minus in it, it'll do the bottom part of it. So I've actually, you can kind of see there's actually 4 points that I'm looking for here. So that's pretty much our starting point, right? Like, so we're gonna have to try and figure out those 4 points. So to find the points, all we have to do is put the equations equal to each other. All right. So the first thing I'm going to do is I'm going to take that second equation. I want to make it simpler. So I've got y is equal to x minus 1 times x plus 1 minus 2. So this could be written as x squared minus 1 minus 2, or I can write it as x squared minus 3. So this is what equation, like from the second curve, I can say y is equal to x squared minus 3. Simplifying it, right? Now the next part I can do is I can actually substitute, well, you can kind of do it either way. Like, because you've got y equals to x squared minus 3, I would actually, because I've got x squared is equal to y squared plus 1, I'm going to get rid of this x squared. So I'm going to rewrite this as y is equal to y squared plus 1 minus 3. And if you think about it, this is what x squared is equal to. So now I'm going to put the left-hand side to 0. So I've got y squared minus 2 minus y, or 0 is equal to y squared minus y minus 2. All right, now I can factorize this. So I can factorize this as y minus 2 and y plus 1. So my two solutions for y is y minus 2 is equal to 0, therefore y is equal to 2. And then I've got y plus 1 equals to 0, which gives me y of negative 1. Now, if you go back to the calculator, you guys can actually see that right here. Of course, I can't click on it. Let's see intersection. Yeah, see, you can kind of see that plus right there, which is at 2. And then if you look at the y mark, that's actually 1 right there. So you can kind of see that 2 and negative 1 is where those intersection points are happening. Now, this is the y value. So we actually need to figure out what the x value is. So what do we got? We've got x squared. Yeah, let's do the x squared one. So when y is equal to 2, we've got x squared equals to y squared plus 1. So we can say that x squared is equal to 2 squared plus 1. So x squared is equal to 4 plus 1, which is 5. And then x is equal to square root of 5. But remember, it is plus or minus. Likewise, when we have y is equal to negative 1, we can say x squared is equal to y squared plus 1. We've got x squared is equal to negative 1 squared plus 1. X squared is equal to 2, because negative 1 squared is 1. 1 plus 1 is 2. And then x is equal to square root of 2 plus or minus. Now, we do need to write down the 4 points of intersection, all right? So the first one is going to be square root of 5 and 2. Our next one is going to be negative square root of 5 and 2. And on this side, we've got square root of 2 and negative 1, and negative square root of 2, negative 1. So basically, that is our 4 points of intersection there that we've just calculated. And by the looks of it, this looks like one of those double excellence questions, which I've seen kind of pop up recently. So correct identification of 2 solutions only of 4 x values. Complete correct solutions with correct mathematical statements. Oh, wow. Okay, so you do need like maybe a statement that says points of intersection. That's your mathematical statement to get a double excellence, all right? So that gives you like 2 E points if you do the whole thing. If you find the because of 2 solutions only of 4 x values. So for merit, no, not merit, sorry, excellence. So this gives you 2 excellence. 1 excellence is if you find 4 x values or 2 points. A merit forms 1 equation in 1 variable, gives you a merit. Wow, this gives you a merit right here. It's incredible. Like forms 1 equation in 1 variable. Yeah, that's what I would say, because that's got 1 variable in it. To get a merit for that, wow, that's very generous. Correct expansion and simplification of curve 2 gets you an achieved. Jeez, that right there gets you an achieved. Very, very generous question, I would say, by the looks of it, guys. Yeah, basically that's it for question 1. We move to question 2 shortly, guys. Okay, so we go to question 2. What we've got here for question 2 is quite a nice factorizing question here. So I'm going to factorize the numerator. I'm going to get x minus 4 and x plus 3 divided by 4x plus 3. And I got my 2 common factors. Let's get rid of it. And I've got x minus 4 over 4 gets me a nice achieved question for this. Man, I remember, but when was it? By 2015 or 14, this question in level 1 used to be almost close to an excellence question. That's how much incredible how it's actually dropped over the last few years. Anyway, let's go to the next question. So question B, what we have got here is write as a single fraction in its simplest form. That means you might need to kind of like simplify it later or expand it, whichever one the case is. So we've got on the left-hand side, we've got 5x and x minus 3. And I always space these out, right? So I've spaced them out because I want to actually see what I can multiply in the denominator. So if you look in the denominator, we have got x minus 3 here, and we've got x plus 2. So what I'm going to do is I am going to put x plus 2 here in the denominator and also in the numerator. As for the other one, I'm going to put x minus 3 in the denominator and also the numerator. So then what will happen is I would actually end up with the same common denominator, or I could actually write it as a single fraction. I mean, that's the whole point of this. So there we go. All right, so in my numerator on the left-hand side, I've got 5x multiplied by x plus 2 plus, no, I copied the question wrong. That should be minus x minus 4 times x minus 3. And the whole thing is now divided by x minus 3 times x plus 2 because they have the same denominator. Looking at the answer schedule, you don't really have to expand the denominator, but you definitely have to simplify the numerator. So looking at the numerator, we've got 5x times x. So I'm doing this thing right here. And then I'm doing 5x times 2. So what I've got here is 5x squared plus 10x minus. I'm going to actually do this these two brackets first. So I'm going to end up with x squared minus 7x plus 12. And that whole thing is now divided by x minus 3 and x plus 2. Again, I'm not really touching that. So I've got 5x squared plus 10x. And because this minus is going to affect all of those symbols, I'm going to get minus x squared plus 7x minus 12. The whole thing is still divided by x minus 3x plus 2. Carrying over here, I've got 5x squared, take away x squared is 4x squared, plus 17x minus 12. And that whole thing is divided by x minus 3 and x plus 2. Now I cannot go any further than this. This is my final stop for this question. Obtains correct fraction is going to get you a merit. Again, generous. Level 1 setup or equivalent is going to get you an achieved. So sorry, not level 1, line 1. So achieved is right there, guys. Like, just to set up this equation, you're going to get an achieved. And I know I've run a couple of tutorials where I spend a lot of time doing these fractions and writing them as in its simplest form. Worth checking them out. Cool. So let's go to the next question here. All right, let's have a look at this. All right, guys, hopefully you pause the video and just read through the question, but I kind of paused it, but I guess I'm recording it, so it really doesn't matter. But anyway, question C, what do they got? C part 1 is if an investment takes 11 years to double in value, what is the rate of return? So we've basically got D is the time. So we can actually say that we can actually put this equation, right? 2000 equals 1000, 1 plus R over 100 to the power of D, which is 11 in this case. Okay, so that's what they're talking about. It's 11 because D is the time. Cool, so let's get rid of the 2000 and 1000, which is going to be 2, because 2000, I'll just do it. 2000 divided by 1000 equals 1 plus R over 100 to the power of 11. So we're going to get 2 equals 1 plus r over 100 to the power of 11. Now, if you, again, and I know I kind of almost keep saying this like in every question, but it's like there's a whole section where I end up doing these types of questions, and there are some really quick shortcuts on how to actually solve this. Now, you could actually put this in the graphics calculator and get the R value if you want to. I'll just show that real quickly. And some people kind of ask me, oh, am I allowed to use it? As long as you set up the equation, right? And then let's look at it. No, actually, no, I might be wrong. When I'm looking at the answer schedule, if you just put the correct answer only, you're only going to get an achieved for it. But if you actually show the working, you can actually get a merit for it. So the way I would do it is like I would still use the calculator to check what my answer is. So I go into equation, go into solver, and I would actually put this up. So I would actually go 2 equals 1 plus r over 100. So I'm going to go 1 plus, you know what? I'm actually going to use alpha r, r over 100. And that's now to the raised to the power of 11. So then I'm going to click on solve. So as you can see, the rate is 6.5. So that's the answer I'm looking for, right? But let me show you how to do this without the calculator. Well, without using the equations function in the calculator. So we're going to rewrite this as 2 to the power of 11, right? So not 2 to the power of 11. We're going to write this as 2 to the power of 1 over 11, because when you do inverse, you actually flip the powers. So this becomes 1 plus r over 100. Now 2 to the power of 11, we're going to go into the calculator, just your normal mode, and we're going to put down 2 to the power of 11. Nope, 2 to the power of 1 over 11, sorry. So when we do that, we're actually getting 1.06504. You know what, we're going to stop at that. So we're going to write this as 1 plus r over 100. Now, if you are good with your decimals, then you know that this is 6.5. I mean, think about it, like this is going back to number at level 1, right? Remember at GST when you go, 1.15 is actually 15% increase, pretty much the kind of like the same idea. So 1.065 is equal to 6.5% is what the rate is. All right, so this is just something that's actually worth remembering, guys. Especially with the rates, when you're doing the rates and you know that when you increase or decrease, it affects the decimal value. And again, watch the tutorial, go through it in quite sufficient detail. So grades wise, we're looking at 6.5 is going to actually get you a merit. But if you just do calculator answer only, it's going to be achieved. So that's that CAO, correct answer only. Sometimes people don't show the working, they just show the 6.5% from the calculator, then you're only going to get an achieved for it. Sets up equation and uses the 11th root, gets an achieved, which is up to here, can get you an achieved as well. All right, let's go to part 2 of this question. Okay, so part 2, what we've got here is, I believe this is just, it's pretty much doing like a proof, but making the D the subject, show that D equals to that. Okay, so yeah, what we're doing here is we've just got to rearrange the equation and then kind of bring D by itself. And again, this is stuff that I cover in those tutorials, but let's go through it anyway. So we're still going to do the 2000 divided by 1000. To kind of do that, we're going to do 2000 divided by 1000 equals 1 plus r over 100 to the power of d. So we're going to get 2 equals 1 plus r over 100 to the power of d. Now they actually want d by itself. This is, I mean, like, guys, seriously, this question is just like, all you're doing is like just taking logs on both sides and rearranging. So you're going to end up with like log 2 equals log of 1 plus r over 100 to the power of d. And remember that when you take logs, the power could actually come in the front. So we're going to get log 2 equals to d log 1 plus r over 100. And then we want to write d by itself, which means d is equal to log 2 divided by log of 1 plus r over 100. Well, that's yeah, that's pretty much it for this question, guys. Like, given expression derived correctly, 1 or 2 lines 3 must be shown. One of lines 2 and 3 must be shown, which is, I'm trying to look, either this one should be shown, one of lines 2 and 3. So either this or either this must be shown to actually get a merit. For achieved logs taken of both sides, one of lines 2 or 3 must be shown. So achieved is actually just doing this, just taking logs of each side. Wow, 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 wow. So merit is you got to do both those two lines and then prove that it's that. Achieved is just taking log of both sides. Wow, straightforward merit question there. Surprised at how fast we're actually going through this question. Because we are up to the final question. Wow, okay, here we go. Last part of this question. Lot to read. I'm going to pause and just kind of read through it. Well, I might actually tell you guys to do the same thing too. Okay, guys, so I'm having a look at this. So what they've got here is two D's. All right, the first one is that D is equal to 72 over R, right? So that's like the rule of 72. And then you've got the actual D here. And it looks like all we have to do is put those two equations equal to each other and rearrange, and we should be okay with it. Because that's what the question's actually asking. It's not really asking us to solve this equation. It's just asking us to put those two equations together and then bring it to that final ugly looking equation at the bottom. So in other words, we've got 72 over R, which is equal to D. And the other D is log 2 of log 1 plus R over 100. So I'm going to cross multiply this. So I'm going to end up with 72 log of 1 plus R over 100 equals R log 2. Because all I've done is I've just cross multiplied both of those things, right? So next thing is I can actually get rid of the logs. But before I get rid of the logs, I want to get rid of the 72 and R. Because remember, those are powers. So I could actually bring it back in front of the bases as powers. So this would be rewritten as log of 1 plus R over 100 to the power of 72 equals log 2 to the power of R. Now, this is starting to kind of like make sense here, because look at this. We've got a 2R there and a 2R there. And we've also got this ugly 1 plus R over 100 to the power of 72 over here. So in the next line, because they're doing both logs, we can just get rid of the logs. You know, it's kind of like, you know, when you have square root of x equals to square root of 4, we just write x equals to 4. So that's what we're going to do here. Both of the logs are going to disappear. And we've got 1 plus R over 100 to the power of 72 equals 2 to the power of R. And if you see now, we can put this as 0 on the left-hand side. We're going to get 2R minus 1 plus R over 100 to the power of 72. And I'm trying to think, but that's pretty much it for this question. A weird double excellence questions, that's all I can say, because I'm trying to think about this. You know, in the last few years we've done this paper so many times, and I know that when it comes to like excellence questions, it is not been able to do it in like 5 or 6 lines. But strange, yeah, this is what they asked last year. So this ends up being like a double excellence obtains final given equation with correct math statements. Yeah. And if you make a mistake somewhere, you can still get an excellence. Processes powers, line 3, processes powers. Line 3 gets you a merit, which is here. Achieved is just putting both of those equations equal to each other. Wow, guys, I gotta be honest with you guys. I mean, I've done these exam papers since 2014, and both of these excellence questions that I've done so far, even the first one was the points one was just, you know, 2 excellence points, 8 points for that question, and then 8 points for this question. It's just, yeah, it's just surprised at how kind of straightforward it is. Anyway, we'll move on to the next question. That's it for question 2. All right, guys. So let's get to question 3. This is gonna be one of those fun, long questions, right? Okay. Let's see. Pause the question. Have a read through it, guys. There's a lot to read through here. All right, so the first question is actually asking us to find the volume of the cube below here. So volume of the cube is going to be, what is it? Base times width times height, whichever one you call it. So we're going to get P over 2 times 2P times P. 2's cancel out, and volume is equal to P cubed. Yep, that's it. That's your first question for an achieved. I'm just finding this entire paper very strange, but I mean, look at how much room I gave to answer that. Jeez. Okay, anyway, let's go to the second part of the question. What do we got? Volume of the cuboid below for this is given that. Expand and simplify this expression. Wow, so we've just got a cubic that we needed to expand. So what do we got? P minus 4 multiplied by P plus 5 multiplied by P minus 3. So I'm going to do that this lot first. So I've got P squared minus P minus 20, then multiplied by P minus 3. So I'm going to get P cubed minus 3P squared minus P squared plus 3P minus 20P plus 60. This is going to be P cubed. Have I made a mistake somewhere? Oh, that should be plus. No, that whole thing is not going to be changed. Okay, so that's going to be plus P squared. That's going to be minus 3P. Hopefully that's right. So we got minus 2P squared minus 23P plus 60. Yeah, straightforward question there for an achieved. 2 minutes to do the first 2 questions. Wow, this is just getting interesting. All right. Yeah, nothing else to it. Let's go to question C. Yeah, question C, what do we got? Are there any values of A which the volume of the cuboid will be same as the volume of the cube? Okay, so we know the volume of the cube is P cubed. So if we were to work out the volume of this particular shape, we're going to get P minus A multiplied by P plus A multiplied by P. So here we're going to get P squared minus A squared multiplied by P. We're going to get P cubed minus PA squared. So this is the volume of the cuboid now. If to kind of, are there any values for the cube will be the same? Well, let's have a look at it. When is the volume of the cube the same as the cuboid? So if we were to do that, volume of cube is P cubed. Volume of cuboid is P cubed minus PA squared. Rearranging this, I'm going to get PA squared is equal to 0 because P cubed and P cubed is going to be 0. So PA squared has to be 0, which means A has got to be 0. So which means A is equal to 0 is the only solution because there can't be any other number. What does that actually mean? Yeah, I'm sorry, guys. I'm just kind of like baffled by the answer schedule here and how these questions almost seem too straightforward. Looking at the schedule here, yeah, that's pretty much all that they have there. Makes correct conclusion with valid working and reasoning, which we've done, which means this is going to end up with a merit. Correct working to the point of equating the 2 volumes gets you an achieved, which is here. Yeah, I mean, you could write a little statement says that the cuboid never has the same volume as the cube unless you leave the sides unchanged or equivalent, which we kind of have already done that by saying that A equals to 0. Yeah, I have to say, Man, I'm just finding this paper stranger and stranger as I get into it. But look, there's nothing else to this question for C. We're going to go to D. And again, so much room. All right, so question D here. Let me pause it and have a read. Okay, so for this question, what we have got to do is we've got to actually work out the surface area of the cuboid. And if the surface area of the cube, which is 6p squared, is the same as surface area, show that. Okay, so we've got a proof question. So first thing we want to do is we want to actually try and work out the surface area of the cuboid. So now surface area of a cuboid is going to be, there's going to be the bottom and top. So two lots of p minus a times p plus a. Then you've got two, if you look at it like from this direction, you could do the p plus a 10 twice. So you've got 2 times 10 times p plus a plus two lots of these ones, which is going to be 2 times 10 and p minus a. So we're going to expand all of this. So we're going to get 2p squared minus a squared plus 20p plus 20a plus 20p minus 20a. We've actually got 2p squared minus 2a squared plus 40p. So this right now is the surface area of the cuboid. So when we put the surface area of the cuboid equals to surface area of the cube, so we're going to put 2p squared minus 2a squared plus 40p equals to surface area of a cube is 6p squared. Is that right so far? Yep, that's right so far. We're going to put this equal to 0. We've got 6p squared minus 2p squared plus 2a squared minus 40p. So 0 is equal to 4p squared plus 2a squared minus 40p. And I can see that 2 is a common factor. So I'm going to take it out, and I've got 2p squared plus a squared minus 20p. And of course, 0 divided by 2 is 0. And I've left over with 2p squared plus a squared minus 20p. And as you can see, this right here is what we were actually looking for. Again, another weird question, strange question, but you know what? That is worth a merit right there. Find the expression of surface area of cuboid and expands it. Okay, so surface area of cuboid can get you an achieved right there. 8 minutes and I'm starting an excellence question for question 3. Jeez, that is, yeah. That's it for this question, guys. All right, let's go to the last part of this question. Seems like a bit of a follow-up question, but yeah, pause, have a read through it, and let's figure it out. So there I am thinking, you know what, this paper, all the excellence questions has been so sweet so far until I get to this one, and I go, wow. It's like one of those maze questions, right? But the good thing is they're kind of giving you a clue here. So they want you to use the discriminant formula, find the largest whole number value that A could take in this context. Right, so remember that we've got this cuboid at the top there. I'm going to go back to the cuboid. We've got p minus a, p plus a, right? Because that's going to come into play. So let's just going to draw that cuboid in the side here, just as a bit of a reminder for us. We've got p minus a, p plus a, and that's 10 right there. All right, I'm going to come back to it, but let's just do the discriminant first. So we've got our a value, which is 2. We've got our b value, which is minus 20. And then we've got our c value, which happens to be a. So we can say discriminant is b squared minus 4ac. We're going to get negative 20 squared minus 4 times 2 times c, which is a squared. Now, discriminant, find the largest possible value, right? So we've actually got to have this greater than 0 because we want to actually have two solutions, right? So that's the idea behind it. Because when the discriminant is bigger than 0, that means there's going to be more than one solution. So that's why we're going to keep this greater than 0. So here we've got 400 minus 8a squared is actually greater than 0. So we can rearrange this, and what happens is we're going to get negative 8a squared greater than negative 400, and then you've got a squared is less than negative 400 divided by negative 8. I changed that symbol because of dividing by negative 8, and I've got a squared is less than 50. Okay, so with that in point, so a squared has got to be less than 50. What do we got? Square root of 50, what is it going to give me? 7 point something. So we're going to go with 7.1. Now, if you look at it like this, right, it's possible whole number, so we don't have to actually worry about a being negative, because you could get negative. So normally you'd say the a value is between, for a squared less than 50 is between negative 7.7 and 7.7. Because if I write like this, so, if I have like 50 there, and then this is the a squared, then this right here is negative 7.1, and then this one here is positive 7.1. But in this case, because it's a whole number, we're going to say a is between 0 and 7.1. And again, we're looking for a to be a whole number, and we're looking for the largest whole number. So I guess the first thing we really want to be doing is we want to put a equals to 7. Okay, and we've got to try and figure out, because if you look at the second part of the question, use this value of a to find the dimensions of both the cube and cuboid. So we're going to actually put a in and to work out what the dimension of the cuboid is. So we're going to actually try and figure out what the p-values are. So we've got 2p squared minus 20p plus a squared. Now, 7 squared is going to be 49, and we're going to put that equal to 0. Now, obviously, guys, I'm going to kind of put this in the calculator to try and solve it. So polynomial degree 2, what have I got here? We've got 2 minus 20 and 49. And as you can see, my p-values are actually 5.71, and my next one is 4.3. So I'm going to slowly take you guys through this. I know this is one of those really strange questions, as I said. So we did this discriminant part, we actually worked out all the way up to here to try and figure out what the a values range is going to be. Because it's a whole number, we only went up to 0 here. The next step is it says use this value of a. So we've actually taken a equals to 7, and we're trying to find the dimensions of both the cube and cuboid. So we figured out what p is, but now we need to actually see whether the cuboid's going to work out or not. And the reason I drew this is because, check this out. We've got p minus a here as one of the sides. Now our value of p here, which is 5.71, if we go p minus a, so let me put this as p minus a, we've got 5.71, take away a, which happens to be 7, we're actually getting a negative 1.29 as base of cuboid. And this is actually not possible. So because it's not possible, we are going to move away from a is equal to 7, and we're actually going to go try a equals to 6, because that's the next largest whole number. So repeating the process again, we're going to put a equals to 6, which means we got 2p squared minus 20p. 6 squared is 36, so it's 36 equals to 0. And we're going to change the 49 to 36 and do our two answers. We've got our two values for p. Our first one is 7.64, and our second value is 2.35. Yeah, 2.35. So we're actually going to look at, okay, which one is the largest value in this one? It's 7.64. So if we do p minus a, we're going to get 7.64 minus 6, which actually gives us 1.64. Now you might be wondering, well, why can't we actually do 2.3? Remember, we're always looking for the largest side of P because if the largest side works, then we don't really care about the small side because we know that cuboids could be turned, 90 degrees this way. That means it's the same kind of, no, I'm explaining that wrong. We're actually looking for the largest p-value, and if that works, then a equals to 6 actually would work, right? So we've done that. We've got p equals to 1.64 as one of the sides. Then we've got p plus a, which is 7.64 plus 6, which is 13.64. And so in this, we can actually say, if it's a cube, the cube would be 7.64 centimeters all sides. So all sides. But if it's cuboid, we're going to have 1.64 multiplied by 13.64 multiplied by 10. And yeah, so based on where we started from, we kind of like tried out a different a value to try and get a dimension that actually worked. And yeah, so this is pretty much what we needed to do for this question. Excellence wise, grades wise, evaluates discriminant gets you an achieved. So I'm trying to think where obtains inequality. Oh, that's a merit obtains inequality. So that's a merit right there. Or a squared evaluates discriminant. So would that be 400 minus 8a squared? So somewhere here is going to get you an achieved. One excellence is doing this part here. Two excellence is doing this part here. As I said to you guys before, it was a really strange paper. I mean, like looking at all these excellence questions, the first two were like generally quite straightforward, easy. And then you look at the third excellence question, it was like all over the place. And I'm like, this is more like the old level 2 papers where they throw you a curveball from nowhere. So yeah, basically, guys, overall, it was actually not a bad paper, to be honest. Like apart from that last question, which was a bit of a annoying little one, everything else seemed to be going well. Hey, just a bit of a heads up for you guys. So if you have any questions about the paper, just drop it in the comments section below. I will try my best to kind of come and answer them. And I know a few of you guys have been asking before. It's like, what's the best way to support me? If you haven't heard, I will share a link of it. I've actually got a kind of like a store happening, so go check it out at Infinity Plus One Store on Instagram and on Facebook as well. But apart from that, I would actually say with you guys, when you actually attempt these questions, when it comes to your own exam time, just make sure that you guys attempt all the questions. Don't leave anything empty. It's amazing what you'll get and achieve for in some of these papers. So never leave a question paper empty. Yeah, so that's basically it for this paper. I think I'm probably going to say that again, but good luck for your exams, guys. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.